Welcome to Academic Math. In this video, I will solve a question on the topic of group homomorphism. Without going further discussions on the topic, that is, on the theory of this portion, I will solve a question given by one of my students. That is, the question is find all homomorphisms from Z6 to Z4. So we have to find out all the homomorphisms from Z6 to, that is the functions which can be defined from Z6 to Z4, the number of functions actually. Solutions. Solution. Now we all know that Z6 is a cyclic group generated by class of 1. Let phi be the homomorphism from Z6 to Z4. Then we have to find out all the possible definition of phi, that is for any arbitrary class of A belongs to, for any arbitrary class of A belongs to Z6, we have to find out all the possible value of phi of class A. What will be the possible value of phi of class A? This we have to find out. We have to find out this result, that is, we can define in how many ways phi A. This will say the total number of homomorphisms that can be drawn from Z6 to Z4. Now phi of A, class of A, which equals phi of, that is, these are additive groups, that is Z6 and Z4 are additive groups. These are obvious with respect to the questions given. Now phi of class of A, which is equals to phi of class 1 plus class 1 which is plus dot dot up to A times. These are A times, which equals phi A, phi 1 plus phi 2 plus phi of 1 plus phi of 1. These are also A times, which will be A into phi of class 1. That is phi of class A will be equals A into phi of class 1. Hence we can say that class 1, hence we can say that phi is completely known. We can define phi if we find out phi 1. So phi can be completely determined if phi can, that we can say that phi can be determined if we can determine phi 1, phi of class 1. So now class of 1 belongs to Z6. This implies phi of class 1 belongs to Z4, and which implies order of phi of class 1, this order of this element divides order of Z4, that is order of phi of class 1 divides 4. This is obvious. Now our claim is that order of phi of class 1 divides order of class 1, that is order of phi of class 1 divides 6. This is true. Now our problem is this: how does it happening? Our question is how this is happening, and that is this, how it is happening. Now this is happening with respect to a theorem, that is there exists a theorem. So there is a theorem if phi is a mapping from Z6. This is a particular case, so we have to discuss universal case, that is there is a theorem if the phi from G to G1 be a group homomorphism, then number 1, phi of E is equals E1, that is E is the identity element in G1 and E is the identity element in G, and phi of A inverse is equals phi A whole inverse. For all A belongs to Z6, sorry here G have G, it will be G. And one more, which is important, the option that I will use is this: if for any A belongs to G such that order of A is n, then order of phi A then order of phi of A will divide n. I would like to prove the last one only, this, that is the last statement of this theorem. Now for this proof of 3, that is the last portion. 1. that is E. Sorry, it will be A. For any A, let A be an element belongs to G such that order of A is n. Order of A is n. Now phi of A belongs to G1 and let order of phi of A sum small m. Then m is the least positive integer for such that order of A phi m, then m is the least positive integer such that then by definition m is the least positive integer such that phi A whole to the power m সমান or equals e1. Phi of A whole to the power m equals e1. Now our observation is that now what will be, now phi A to the power n will be equals to phi A plus phi A plus phi A n times, which will be equals phi of A plus A n times, and which will be phi of A to the power n, and which equals phi of, we use this notation that is the additions are equals to A to the power n by the definition of the cyclic group, that is by the definition of the group. Now as we know that order of A is n, this will be E and which will be E1. Therefore we know that order of phi of A is equals m, and here we have seen that phi of A to the power n is equals e1. Therefore we can conclude that m divides n, as m is the least positive integer, that is order of this phi A, and that is order of phi A divides n. This completes the proof of the theorem, this the third portion, and here it is applied in this problem, this theorem applied here. Now here we have seen that phi 1 is an element. Here, for this problem, to clarify the problem, that is we know that order of class 1 is 6. Now phi of class 1 to the power 6 equals phi of class 1 plus phi of class 1 phi of class 1 6 times, and which is nothing but phi of class 1 to the power 6, that is phi of E, that is the identity element in Z6, which is class of 0, and which is class of 0 in Z4. The identity element in Z4 and Z6 are same as, and which implies that order of phi of class 1 divides 6, because we do not know the actual order of class 1. We do not know, because we do not know the actual order of class 1, that is in the class of phi 1. Phi 1 belongs to Z4. We do not know the order of phi 1, that is order of class of phi 1 we do not know. If it is m, then it will divide 6, because phi of class 1 to the power 6 will always be equal to e dash, that is e at Z4, the identity element of the image set. That's why order of phi of class 1 will divide 6. Hence, so this is our next equation, that is equation number 2. So from here, order of phi 1 divides 4, and from 2, order of phi of class 1, that is order of phi of class 1 divides 4, and order of phi of class 1 divides 6 also. So we can conclude that we can conclude that order of phi of class 1 divides both 6, and order of phi of class 1 divides 4. Hence order of phi of class 1 will be the GCD of 6 and 4. Sorry, it will not be GCD, it will be the common element of, that is the common factors of 6 and 4. So order of this divides 6 as well as divides 4. There are two elements, that is either 1, order of class of 1 will be either 1 or 2, because only 1 is common in between two integers 6 and 4, and 2 is also common, that is the common factors. So if order of class of 1 is 1, then so order of phi of class 1, that is it will be either 1 or 2. So now the elements of Z4 are class of 0, class of 1, 2 and class of 3. Now order of class of 0 is 1, and order of class of 2, which is order of class of 2 is 2, that is 2, and order of class of 3, which is equals 4, and order of class of 0, 1, 2 and 3 and 4, class 0, 1, order of class 1, class 1 will be order of class 0 is 1, order of class 2 is 2, and order of class 1 is 4, and order of class 3 is order of class 3 is 4, and therefore so phi 1 phi of class 1, so phi of class 1 will be equal to 1. Either phi of class 1 will be either 1, that is class of 0, or either class of 0, or phi of class 1, or it will be class of 2. So so phi 1 can be class of 0, and phi 1 can be equal to class of 0 and class of 2. So these are the two possible definition of class of phi 1, phi of class 1, that is phi of class 1. Now let phi of class 1 is class of 0, then phi of a class A will be equal to a into phi of class 1, which equals a into class of 0, and which is equals to class of 0, that is phi of class A is equals to class of 0. That is the trivial, this is the trivial homomorphism, that is phi Z4 defined by phi of class of A equals class of 0 for all A belongs to, for all class of A belongs to Z6, for all class of A belongs to Z6. Now for all class of A belongs to Z6, and the another definition of another homomorphism that we will get from Z6 to Z4 is if phi of class 1 is equals to class of 2, that is phi of class 1 is equals to class of 2, that is the second case. In this case, then if phi of class 1 is equals to class of 2, then we will get the homomorphism as phi from Z6 to Z4 as phi of class of A is equals to A into phi of class of 1, and which will be equals to A into class of 2, and which is equals to class of 2A, that is phi of class A will be class of 2A. So finally we will get there are two different possible homomorphisms from Z6 to Z4. So finally we can say that we can find there are two possible homomorphism from Z6 to Z4. One is the trivial homomorphism, the another is phi of A will be equal to class of 2A. I think this is clear, and the point where the doubts can be generated I have already discussed here. If there is any more doubt, then please make comments the actual portion where the doubt is located. Okay, then I will find a solution in this with respect to the questions or asked there. I will try my best here to give you the actual position where the students ask, most of the students ask here, and where the problem generated. Okay, thank you.